I'd like to introduce Ben. So I've been going to Ben's meetup for about a year and a half. And if you're interested, what's the name of your meetup?
Graph Database LA.
Graph Database LA. He'll tell you a little bit more about himself, but what I realized, I knew as a marketing person that the future of two things depended on a graph. I started to see it. I knew the future of marketing. If you don't have your own branded graph, you cannot have a connected customer strategy, period. If you are built, number two, smart things. If you want smart products, smart robots, social robots, any smart self-driving car, Tesla, it needs to record the user's experience and preferences in a graph. So the next car you get into knows what I like in terms of my self-driving car, address, settings, etc. So think of it as your AI's memory bank. It's a short-term and it's long-term memory bank. I realized it does two things. It provides real-time service. It gets to know me and matches relevant things. But it's different than a recommendation engine because recommendation engines say, you looked at this product, here's another one just like it. This actually can get to know me and say what's good for me. And you'll see an example at the end of his presentation. The capstone example is an example like that. The second thing I realized was that it's the basis of AI because the AI reasons over the graph. Excuse me. And in this case, it's traversal algorithms, not statistics, not statistical algorithms, not heuristic algorithms, but traversal algorithms. And he's going to touch on that. So if you are familiar with Facebook's social graph, Google's graph, Walmart's graph, Target's graph, BBC's graph, they're all built on this. So for those of you in marketing, this is your future beyond search and beyond social. And for those building robots, this is your future for the memory of your customer's experience with the robot and how it wants to relate to the robot. Okay, so that's why I thought he was perfect to kind of be very early in the game in our presentation to our group. So I'll turn it over to you.
Thank you, Terry. So my name is Ben Nussbaum. I've been working in software for about the last 20 years, touching everything from the software architecture, design, implementation, through database design, implementation to server infrastructure. Kind of done that full stack. In the last decade, my brother and I have had a company focusing primarily on delivering software for the enterprise, so globally distributed systems. And in the last 4 years specifically, we started getting into graph database technologies. We had the opportunity, and our first use case for it was a complex media asset management workflow where we were dealing with identity access management issues because you have many different vendors bringing together different media assets to deliver a final video spot for, say, the 5 o'clock news. And we just started seeing that in identity and access management, permissions were really about the function you were performing at that time rather than your position in the company. And most existing identity and access management are very hierarchical and about position. And so they didn't really fit the model well. And so with graphs, we were able to represent that model very effectively because it was more about the specific context of the relationships you had. And after that experience, I just started seeing all of the problems that we'd solved in the past and all of the problems that we were starting to solve going forward as being graph problems. And when I say a graph problem, it's really about the connectedness of the data. The complexity of data is really about the size, the structure, and the connectedness. So if it's very connected, it's complex data. Tonight we're going to talk about knowledge graphs for a connected world and why they're a good foundation for learning and artificial intelligence. So in Web 3.0 and the semantic web, companies are really amassing more and more data than they ever have, and by and large it just sits there and it stays unutilized. And the need to amass data and collect it is crucial, but then in order to utilize it, that's where the graph comes in, that's where the connectedness comes in. And so there's many different graph database technologies out there that enable that. The one that we've been working with, and I'll touch on why we've chosen Neo4j in a little bit when I talk about the way it works, is just because it provides guaranteed consistency between two nodes, and it's a native graph database. It's been built from the ground up for optimal graph traversal. It's not just an edge cache, or it's not just made for one-hop relationships. It's about how do I start with something in the graph that I'm interested in and look at everything around it that's connected to it. So as companies go and want to connect more and more data in meaningful ways, graph databases provide a very great foundation. One of our use cases that we've been working with is the entertainment graph. So they're bringing together not just one entertainment type, but all movies, TV shows, books, games, and music into one location, and enabling really good social discovery and personalized recommendations regardless of where you consume that content. And that graph today is over 560 million nodes, 1.8 billion relationships, and 3 billion properties. And it basically breaks down the walled gardens of entertainment where you get, Sony makes their deals with Netflix and their deals with Amazon. And if you're in Amazon, you only get recommendations based on what's in their catalog. And if you watch on Netflix, you only get recommendations on what's in their catalog. And if you listen to iTunes, you can't share your playlist with Spotify, with somebody that listens on Spotify, and so on. And so by building that connectedness, we can bring in all of these sources and create kind of a master record of, the Avengers or of Taylor Swift's Red, and whichever one it is. I forget. The CEO always uses that as an example. And basically, it lets you break down those barriers and bring all that data together and connect it in a meaningful way for your real-time interactions with the applications. And so graphs have been around for a while, like Terry was saying, with Facebook's social graph and Google's knowledge graph. And they saw this as a need for connectedness. Now, they're not using Neo4j, but they've kind of built their own internal technologies for their specific needs. But in the last, since 2003, when Neo4j started, they really saw that there was a need for an off-the-shelf graph database solution that could come in alongside the Oracles and the Microsoft SQL servers of the world and provide that connected data solution. And so since 2007 when they open sourced it and 2009 when they took their first round of funding to today, they've been the world's leading graph database, pushing forward that technology and really creating this space. We've been a solution partner with them since very early on, and as the market's matured, there are platforms that are available to help brands and ventures utilize this and leverage it. Because it is a new technology and the graph space is still very young, there aren't a lot of individuals with deep experts like you would find with MySQL. Now they've had 33,000 developers go through their developer course, so there are more and more individuals that are gaining experience with graph. And there are other graphs out there as well, but there are starting to be platform offerings that can enable you to get up and running very quickly. And then there are solution partners that have deep expertise in implementing these graph technologies as well. So we're going to jump into, kind of where do graphs fit in the overall scheme of things, and look at why that's the first step and what makes it a good foundation, and then just talk a little bit about how graphs work. So if you think about the structure of data, if you're amassing data, kind of that bottom layer is just ingesting all the data. It's bringing it all in, getting it stored. And on top of that layer, what you really want to do, and whenever we talk to different enterprises, you want to be able to plug in a graph right alongside it. Most graphs aren't going to be your initial store for if you're writing petabytes of data to disk a day, or terabytes. If you have 100 terabytes hitting your servers every day, you're probably not writing that all into a graph. But you're going to have your big data lake. There's still a place for that. Graphs aren't going to replace it, but they're going to work in a very symbiotic relationship right alongside of it. You're going to plug it in and start bringing data out of your data lake across the different departments and connecting it in a way that's meaningful for your entire enterprise. Because Neo4j has a flexible schema that lets you bring in different structures of data in terms of the properties that are on the nodes, even if they're considered the same type or labeled with the same label. For example, if you have a source movie from iTunes and a source movie from Netflix, they could have totally different properties, but still be considered a source movie. And so you can look at all source movies and do matching operations to try to say, okay, is this the Avengers? Is this the Avengers? They're the same. Okay, connect them and say that they're the same. And so graphs let you do that across all of your different departments, all of your different divisions, bringing all of your data together as an enterprise and creating a holistic view. And then once you have that connected data, you can start to use patterns to reason across your graph and look at the connections that are important. The thing about graphs to remember is it's all about the patterns. It's kind of a shift in mind. You're not thinking about how do I do the, just take my data, put it in a matrix and do an analysis on it. It's what patterns in my data for how things are connected to each other are important, and looking at those patterns. And so then once you've done that, you can get really good personalization from a very dynamic perspective, because I, as a user, as soon as you draw one new relationship, from me, as you learn about me, then your algorithms can take advantage of that right away. So Terry.
This, I just want to remind you that this upper part is our path to learning artificial intelligence for ourselves and for our AIs. For those of you who are new, what I did was I interviewed a lot of the members. Thank you, Chip. Thank you, everyone I talked to. And we boiled it down into 4 levels. This is semantic computing. This is machine learning algorithms. This is deep learning. And this is human and machine interaction. And in 2 weeks, I'm going to have a primer online that actually takes each of those 4 topics and breaks them down into all their simple main ideas with all the learning resources that I've gotten from the group. So everyone will be able to use that primer. It's a PowerPoint deck just full of links. We can make it better over time, but it will help all of us get all the big picture and the fundamental ideas on the path to AI. The presentation I gave on this primer and all the key ideas and the outline is already in a file on the Meetup group. So you can get that and download it. You can also email me at terryrib@gmail.com and I will send it to you if you can't download it for any reason. So what I asked Ben to do was walk through each of these: semantic computing, machine learning algorithms, deep learning, and human and AI interaction, and tell us how a graph relates to all those. So thank you for letting me jump in. So go back and just tell us, each of these sections.
Yeah, so the initial step with the knowledge graph, it's really about establishing the connectedness and getting your data from their disconnected state into a connected state. And then once you have it in that connected state and the relationships that are very contextually specific exist, you can begin to look at the patterns in the graph that are important. So that's kind of the algorithms that reason over the graph. You can do very large-scale graph analytics. So instead of just relying on disconnected entities and their properties, you can now do analytics on the patterns in the graph themselves. Some of the frameworks that we've built allow you to do distributed graph compute with your graph in its connected state, so you can scale out your graph across n number of instances, doing computation, looking for patterns in the graph that are significant and important, and then drawing some conclusion and routing it back. I'll get into this in more detail, but one of the key things with graphs are both nodes and relationships have properties, and so you can take advantage of weighted edges throughout the graph. So if you're dealing with networks or looking at scoring different edges, that's a very powerful aspect of the graph because relationships are first-class citizens.
So that feels very neural network-like in that sense. So how does it relate to that, which I think you were kind of alluding to?
So the graph database is not a neural network. It doesn't have the algorithms. It's a storage structure, but it stores it in such a way that it's very friendly to those types of traversals and looking at the patterns with the weighted edges. It's very geospatial friendly as well. The road networks, it's literally it's a graph. So we'll get into some of the use cases, but logistics is a good use case for graphs. And so then, with the graph, you can also look at things over time very quickly. So modeling time series data. So that's kind of some of the learning as things go, as you see the edges change, as you see the graph evolve through that. And then they're really powerful for the personalization and the recommendations from a dynamic perspective. If you need 10 ms response time, you're probably going to have to just pre-compute everything because you don't get much time to, like an ad exchange, you don't get more than about, okay, go do an index lookup and return the value if you have to be under 10 ms. But if you have a couple hundred ms, you can do a lot of traversals very quickly. We built a recommendation engine for the entertainment graph that one of the use cases is date night movies. And it can take into account basically 2 movies, compare them. So like Gladiator and The Notebook, it's trying to answer that question of what should we watch tonight. So if I want to watch Gladiator and my wife's like, let's watch The Notebook, it'll take those 2 and mash them together and basically look at all the characteristics of all of them and try to return recommendations that we both might like. And then similarly, for a personalization feed, all the movies that I've liked or actors that I follow, kind of everything that my taste profile about entertainment content, it can take all of that into account and look at all of those And then in real time, if I like one more thing, it now can update. It doesn't have to do an offline pre-compute because it's looking for patterns of what I've liked, what I've followed, in the ways that I've interacted with it. And then it can look at all of those things, what they're connected to, and score them and order them in real time based on either the page that I'm on, what I happen to be looking at now as a user. So it's very dynamic and personalized in that sense, and you can do it very sub-second when you're looking at 50, 60, a few 100,000 things that could be recommended. So the way that businesses operate is changing. They used to have very set business systems that existed kind of in the back office and were very disconnected from the consumer and the way that us as consumers were interacting with their brands, with their products. But as the world has become more connected, these things are all coming together. And businesses are starting to want to create more engaging experiences with the consumer and look like, hey, we understand you. We don't want to just guess and kind of shoot in the dark and have our systems and make it very unpersonal. It needs to be more personalized. If I've been shopping with, this store for years, they should have a pretty good idea of what I'm going to buy, what my patterns are. And you also want to be able to connect different systems. So, if you have digital properties and physical properties, being able to bring that all together and create a holistic experience for me as a consumer is really what graphs are about, because those kind of lets you blend the connected experiences that we as consumers have with social media and everything's connected with the business operations and kind of how they see the world. So getting into kind of what is a graph, what are we dealing with here? Essentially, where the graph database originated is deep in graph theory. So Leonard Euler, he's one of the founders of graph theory, a lot of our modern mathematics. Basically, you have edges and vertices. We call them nodes and relationships. So the nodes are the circles. Those are the things. So essentially here we have a person, which is Jane. We have her node. And we have a hotel and a room. Those are all kinds of things. And as you model with the graph and discuss it, you'll notice that it should sound a lot like English, like you're speaking. It's very contextually specific. So you should be able to talk through the graph and how things are connected. And that's literally how it goes onto disk and how it gets stored and laid out. So with this, you basically have a node that has a person label. And a label is a way to group nodes. So a label is really like a tag. It's not one node can have more than one label. So you could have a node that has a person label and also has an actor label. And the way that Neo4j uses those is it basically indexes, and it maintains the index for you, but if you give a node a label, you can say match some label, like match n person in your query language, and it will narrow to that subgraph of just the person nodes. And then if you say match n actor, it'll narrow to just the actor nodes. And so it's a way to narrow the set of the graph that you have to look at. So if you have 500 million, a billion, 10 billion nodes in your graph, the way that one of the keys is getting to the smallest starting set as quickly as possible. The next part is the relationships. These are the contextually specific elements of how things are connected. So in this case, we see we have a person who prefers a hotel, and that hotel has available some rooms. And so we basically can talk through the connections and how things are related. And the relationships basically get grouped together around a single node. So if you have a node and it has many different types of relationships coming in and going out, the main rules around relationships are that a relationship must always have a starting node and an ending node. You can't have a dangling relationship. And that's why it's very important that Neo4j is a native graph database, which differs from a graph layer on top of an existing database or some document graph hybrids, simply because as a native graph database, it's a fully ACID compliant transactional database, and they guarantee referential integrity, which basically means that when you write data, if you write a relationship, both nodes will always agree on the relationship between them. And that's incredibly important for a graph, because what you don't want in your graph is a scenario where two nodes disagree on the relationship between them, or you have a node with a relationship that's not connected to another node. Those cause a graph to fundamentally break down. And so a lot of what we're seeing in the industry is Neo4j has taken the last 13 years to build this native graph database. They've raised about $50 million in funding to date. For other companies coming later to the market, they're all taking shortcuts. They're doing graph layers on top of existing data stores because it's much cheaper. If you're at Oracle and you have an existing database technology, it's easier to put a graph layer on top of it and just make it feel graphy. But the real low-level underlying issue with that is how the underlying data store writes data. It doesn't have the concept of locking two nodes to guarantee that the relationship between them is agreed upon.
Elasticsearch is doing that in the next couple of weeks.
Right. So Elasticsearch is even worse because, one, they're not even ACID compliant as a NoSQL store. They're not transactional. So they even have more things going against them in terms of writing data and having it agree. So what you can end up happening is, one example is if I have Jim and he works for Emil, so Emil's the CEO of Neo Technology and Jim's the chief scientist, and at some point Jim says something in his closing keynote, Emil fires him, right? If it's not Neo4j that's writing that relationship, you could have a scenario where if you query the graph from Emil's perspective, he'll think he fired Jim, but if you query it from Jim's perspective, he'll think he still works for Emil. And so you've created
So
this.
everybody wins.
Yeah. Well,
It's office space, yeah.
except the people that are trying to maintain the graph and maintain the integrity of the data within it, because those are the hardest problems to track down. When you're dealing with terabytes or petabytes of data, it's hard enough to keep it all doing what it's supposed to be doing. You don't want to have to deal with these hidden, inconsistencies. Now, what these companies will do is they'll build algorithms that try to figure out the transactions and mend the database. But in the people that I've talked to that have been doing that, they've had huge MapReduce jobs just running overnight trying to mend that process and get the data back into an acceptable state for the next day, and it just ends up being not worth it. So with Neo4j, you do pay a slight penalty on the write because it has to lock both nodes, but I accept that penalty and prefer to have my data in a consistent state. And I haven't had a scenario where I haven't been able to write fast enough to push the data through that I've needed to. And we've dealt with some quite large data sets, like the entertainment graph. It brings in more than 190 different sources on a daily basis, flowing it all into Neo continuously. So there's a pretty full ETL pipeline there. So then the other thing that I mentioned a little bit earlier are the properties. So both nodes and relationships can have properties, which is incredibly powerful when you're dealing with graph theory and being able to look at edges and do algorithms that are traversing from nodes to relationships, and you want to or nodes across relationships, and you want to understand how much is this thing connected to this thing in this way. So like if Bob loves Sally, how much does Bob love Sally? Maybe he's like a 0.3. He's kind of on the fence. He's not sure. But Sally loves Bob like 0.9. She's all in and crazy, right? And so now you've started to build this very contextually specific relationships of how much do I like the Matrix? How much how much sci-fi is the Matrix? How much comedy is the Matrix? Nothing is usually black and white. It's not all or nothing. So when you're dealing with these relationships and being able to put properties on them, you can get very granular. And that's where a lot of the reasoning comes in. And so as you build your algorithms and you're looking at the graph and analyzing it, you can use confidence scores. You can compute that and then store that on the relationship. So if you're doing, if you're building out a fraud network and you have, somebody was in contact with this other person and, how many degrees away are they from, El Chapo or something? These are real scenarios. If you get on a designation list, it's not only you that's important, it's everybody that's connected to you. Right. And so if you get sanctioned by, a government out there, that's a big deal. Not just for you, but for you in the network and any financial institutions that may be doing work with you, right? So being able to build confidence scores of, well, how much do we trust this source that we have that said these two people are connected? So being able to build out those types of confidence networks. You can do that with the properties on the relationship. So that's kind of the different traversals and then the algorithms using both the weighted edges and the properties, being able to do it in real time and make it dynamic. So in this case, we could look at Jane's all the preferences around her to see which hotels she prefers, and maybe if you put a weight on that of how much she preferred the Hilton versus the Marriott, then you could look at which hotel do we recommend to her, and maybe where is she staying, what's she close to, even if she's further away from the Marriott, but if she happens to prefer that more based on her past, maybe we recommend she drive the extra 10 minutes to get to the Marriott and stay there instead of the Hilton.
Can you talk about the difference between this kind of thing and the layered thing, like say the difference between Neo4j and GEFI or NetworkX or something like that? Like how would I know using those that would be different?
Yeah, so a lot of, so it depends. There's a lot of different databases out there. So what you'll want to look for whenever you're picking one is, what's this built for? Is it an edge cache? Because there's a lot of those, like FlockDB.
But now those are not, some of those are programs, not databases, like NetworkX or those kind of things, right? Or more.
NetworkX?
Yeah.
I'm not familiar with NetworkX.
Oh, okay. Well, it's like
GraphX?
Python's
GraphX?
Well, it's like
Spark
well,
graphics.
graphics is like Spark, yeah.
Yeah, so that's more of a distributed graphy layer that lets you do compute in graph-like ways. It's not actually a database to store the data.
Right.
Gephi is a visualization tool, if I'm not mistaken.
Can I see those kind of connections into those? What more does Neo4j give me by having it be a database than using that layer?
So as a fully ACID-compliant transactional database, it can be your source of truth database. So with the entertainment graph, there is one database. It's Neo4j. And so that basically replaces MySQL or Oracle or the need for any of those. Now they're not storing petabytes of data. They're not actually storing the media content for distribution. It's just the metadata about it. So on disk, it's about 400 gigs. That's fine. Neo4j runs with IBM's Power 8s. So if you want to go up to 56 terabytes of near in-memory access through their CAPI-IO controller, you can do that. You want to connect a dedicated SAN to it and mount that for your drive, you could go up much larger than 56 terabytes. So you can throw a lot of data into Neo4j. So it's meant to be a source of truth database that, initially when you're bringing it into your enterprise, it's always dangerous to rip and replace. So you kind of want to plug it in alongside the existing stores. And over time, what we think we'll see is companies will begin to retire Oracle. They'll begin to retire these other databases after they let their real-time, initially you'll siphon data and write to both and let your real-time applications that want to do recommendations or these types of, more dynamic graph traversal type apps interact with Neo, and then you'll slowly start migrating. Because it takes a long time if you've been invested with an Oracle to migrate to a real-time solution that's more about the connected data. But that's the direction we see enterprises going.
And when do you steer somebody away from the MySQL, SQL servers towards this on a new application?
As soon as the way the data entities are connected is important. When you want to ask questions that are concerning how things are connected, that's when you want to use a graph.
Because this feels like tables and, it has that SQL-like feel a little bit where, the person feels like a table, the properties feel like fields.
They are. So
one of the foreign keys seem like your connection's a little.
So they are, except you're dealing with very specific and concrete connections. You're not relying on foreign keys to try and go figure out what things are connected. And there's no join pane. So one of the biggest things with Neo4j as a native graph database, once you get to the starting point in your graph, like once I get to Jane, as I traverse out from that node, it uses index-free adjacency, which is a constant time operation. It's literally just a memory pointer from Jane to everything she's connected to.
Without joining the whole table.
So there is no join. It's index-free addition. It's literally a memory pointer. So if I'm at Jane, every relationship coming into Jane or going out from Jane is a memory pointer. So that's like nothing in terms of clock time. So I can very quickly, and Neo4j on commodity hardware can do 4 million node traversals per second per core. So I can pull myself out of my network and look at my first level, my second level, my third level. Like I can go out very far and do very complex analysis very quickly because there is no concept of join. Like you're literally just looking for the patterns. So if I want to look at me and my first level connections and all of the movies that they like to try to determine what I should watch or how they've interacted with it, what they've rated it, I could do that in just maybe 100 or 200 ms. Probably less because my first level connections are many.
Oh, yeah. There
Yeah,
you go.
and so the way that you query the graph.
That's the difference.
Yeah, so that's the difference. The way that you query Neo4j is with Cypher. That's their query language, and it's a declarative pattern matching language that's designed for matching patterns in the graph, because in Neo4j it's all about the patterns. And so instead of thinking about how do I join these things together and creating a bunch of tables in the middle to get at the data I need, it's more what are the connections that are important. And so your developers, and as you're building, I've honestly never had as much fun querying a database as I had with Neo4j. It's so simple, and you're not just sitting there thinking about joins and table joins and normalizing and then denormalizing to get performance and like going this constant battle. You literally can write in these complex relationships, and if you need another relationship to connect it, because every node can have more than one relationship. So Jane could have many relationships coming in and going out from her, and even multiple relationships to the same node. So maybe she's married to Bob, and she likes Bob, and she follows Bob on Twitter, as well. So you can have all of these same different types of connections. In this case, it's basically looking at a management hierarchy. Who reports to whom, and what is that entire structure. And so what you see there you basically have match some node. It looks like ASCII art, so you can imagine that kind of the parentheses are the nodes. They're making the circle. And then the square braces are the relationship. And then you have the direction that the relationship is going. So every relationship is always directed. And in this case, it's basically the manages relationship. And the asterisk, 0.3, basically says, start with this node, basically start with John Doe, and look follow the manages relationship 3 levels out. So go look at his first level reports, second level reports, third level reports for basically everybody that reports the whole way out, and go bring all of those back and count them. And we're going to see, how many total reports does he have in his hierarchy that he's overseeing. And that will probably take, just 20, 30 ms. It'll be a very fast operation because you don't need to go and join and join and join across every one of those levels and all of those tables and so on. It's just going to pull him out of the graph and go and get it. And so this was an example that some developers sent in when they were transitioning from MySQL to Neo4j. They were like, I was able to replace all of this with this. And so when you're dealing with connected data, it's just much easier and more efficient to work with. And then there's a lot of powerful graph algorithms that you get exposed to and you get for free, like shortest path. If you've ever tried to build shortest path in MySQL, I'm sorry, it's very painful. In Neo4j, it's literally a built-in function. They also have A-star, Dijkstra. Like you can use these different types of graph algorithms, and you literally just call it as a function that's built in, and you can pull 2 nodes out and look for that pattern and say, show me the shortest way to get from this node to this node.
So like Google Maps, would that be an example of that? Shortest way to get to this address?
Wanted to do it based on distance. So Neo4j does have geospatial support, so you can basically bring in any GIS data into Neo and do bounding boxes and kind of all of that, because it's literally just a graph.
Probably Google Maps or Bing or internally they probably use a graph database.
Yeah, a lot of the big companies like Google and Facebook and Bing, and they started building their own graph technology that's specialized for them. And I think what Neo4j saw or Neo Technology, the company that initially made Neo4j back in 2003, they were like, hey, we need a graph for what we're doing. We're sure other people need it too. And Emil's joked, if I knew it was going to take, nearly 15 years to build this graph database, I might not have done it, but we're glad that we did, and I certainly am. It's been much. We've been able to solve problems with it that you just really couldn't have solved otherwise, at least not easily, and at least not without a lot of pain. So it's made our team much more efficient in building solutions. So how do you actually work with it? What's that process? One of the biggest benefits of a graph database is it's whiteboard friendly. What you draw on the whiteboard when you're talking about the concepts of how you work together, how things in your business are related and those relationships is what goes into the graph. There's no longer a process where I come and talk to product people, CEO, talk to everybody about the business concepts that are important and then disappear into a room and draw out an ERD that I then come back and say, this is what we're going to do, and everybody's eyes glaze over and they say, yeah, okay, that seems right. And then we go build it, and we get to the end, and they're like, oh, well, these things aren't connected in this way. Okay, well, let's do data migration and migrate this, and there's no longer that process, because literally what you draw on the whiteboard is what goes into the graph. And so all you're doing is taking that and converting it to Cypher or to a Java plugin code, and there is no longer that need to have that disconnect and hope that the software architect or the database architect understood what the business product stakeholder was trying to communicate. You guys everybody can agree. And so the subject matter experts and the graph experts work side by side. And so you can all just talk about that model and what you're trying to, how things are related and what you're trying to achieve.
Couldn't you do that anyway with a SQL database? And you just have to translate that graph into entities and joins. I think it's a
You
great
can,
idea.
but when have you ever seen a product person actually understand an ERD after you finished it?
I think it's great. That makes a lot of sense.
Yeah, I guess my point was, if
Yeah.
anytime I've finished drawing an entity relationship diagram with all the joins and everything, and I've tried to show it to like a product person or a CEO, like somebody that's not technical,
Right.
their eyes just kind of gloss over.
Or what I mean is, in the previous slide, drawing it like that, but then when you take it into the back room, translating that for the engineering team into an entity diagram.
You could, but then I would just ask, why don't you just use
Use
a graph database?
Is that the right notation? Is that the official formal notation, how you represent a graph model?
Whenever you're talking about it, yeah. You literally just draw out nodes and relationships. And the best rule of thumb when you're doing your data model, use a real use case. Don't make it abstract. Don't talk about a person and a movie. Talk about, Keanu Reeves and The Matrix and Andy Wachowski and Ben, and he likes The Matrix. Like, draw out that real use case, because that is what your data you're going to be writing into it. Because with Neo4j, it's schema free. So you don't start out at the front and define a schema. Like, you don't define, I'm going to have a person, and I'm going to have a movie, and I'm going to have an actor, and I'm going to have a restaurant. Like, you don't define those generic concepts. Whenever you write the data into your graph, that schema comes into existence. Now, you do get to define indexes and constraints, and those are all based on combinations of labels and properties. And so whenever you're doing your data modeling, you want to deal with a real use case and look at those, because that'll help you flesh out exactly how things are connected. Yeah, and then once you've got that data model, you'll basically go and look at where you're getting your data from, whether it's an application that's creating it, or you have some ETL process or another database that you're extracting and transforming from, and you'll just make sure that your application and those processes are transforming the data into that graph model and then writing it into the database. And that's what the engineers would do. And then whenever it comes to building algorithms that are all about the graph, it becomes really about the quality. How good is this algorithm? And so there's a lot of different people involved there, from the subject matter experts that know what good quality looks like. If you're trying to build movie recommendations, you need somebody that understands the nuances of all the movies, that can say, yeah, these are good recommendations based on the starting set. And then you need data engineers that can make sure that the data that you're testing with is good, build out different test cases, and then somebody that's designing and building the algorithm. I built the algorithm for for date night movies and the entertainment graph, and the initial pass at it took me maybe like 2 or 3 hours before I was just exploring the graph, playing with it, looking at what was there, and saying, what data do I have to work with to actually return recommendations? And after we'd spent, I did that initial thought set, and I was like, oh, these are actually pretty good. Let me take them to, the experts in-house, the subject matter experts that would actually know if these are returning good recommendations. They played with it for a little bit, and they were like, these are actually really good.
3 hours in.
Yeah, no. But then we spent, the next 14 months building in different ways to filter it, target it based on, weight different things differently. Like, I want, movies like Gladiator, but that only have Tom Hanks in it, or, different things like that. Answer all of these different variations, these different questions, and make it a real powerful rec sys that could, be licensed to other companies, or, compete with like a Netflix. And, a lot of companies want Netflix style recommendations, but they don't know how to get that and build that internally. So yeah, there was that whole process, and then creating different personas or starting sets to try to qualify the data. One way you can do it, it depends if you're doing collaborative-based filtering with your rec sys or content-based filtering. If you're doing collaborative filtering where it's about users, then you'll need a lot of user data so that you can kind of look at, okay, what did they like in the past, build some algorithm that takes that into consideration, and then look at that, what's that next thing we should recommend to them. And so you can build all of that out, but you just want to put those checks in place where you're working with the subject matter experts that can, kind of make that opinion to say, okay, yes, these are good, these are bad results, and try to quantify it in some way. So whenever you're working with all of these different layers, from ingesting data to getting it to the graph and looking at building the algorithms, the platform experts and people that can actually deal with the big data, bringing it in, helping to build the algorithms, and then doing it at scale, that's one of the things that can really give you a boost as you're getting into graph. It can help you get a head start and not run into a lot of the hang-ups that exist with any new technology that you're trying to introduce into the enterprise for the first time. And so a lot of what we've done and tried to provide is just being able to get up and running quickly and focus on your business use case. And so that's where the platform experts would come in. People that have deployed Neo4j in production at scale, or built algorithms and those types of things. They can provide a lot of guidance very efficiently. So graphs in action. There's a lot of use cases where graphs are used. The common ones that people think of are the social graph and Google's knowledge graph. Master data management's a really cool one because you can really think about graphs in layers where you can bring in, if you're trying to master your data and find that one single movie like the Avengers, but you have the iTunes Avengers and the Netflix Avengers and the Amazon Avengers, those can all be sources that come in at kind of a source layer. So you can kind of create source movies and then have algorithms that look through those source movies to match and say, okay, are these the same Avengers or are these the same Gladiators? There was one made in '92, but we all know the one that was made in 2000. Totally different movies, different themes, everything. But if you weren't able to differentiate, and the graph can help with that master data because you can look at the connectedness. You're no longer limited to maybe certain tables or disconnected data. You can look at the network around it and do network analysis to say, are these two things the same? Are their networks similar enough that we can determine they are the same? And then create that one master set. Identity and access management, I touched on that already. Graph-based search. So one of the combinations that we do is pairing Neo4j and Elasticsearch. You can use Neo4j to enhance your search. So you get a query into Elasticsearch, which is really good with text-based analysis. But now if you want to enhance it for a user, based on the user that was making the search, you can look at their network to make it more personalized and boost certain documents kind of dynamically on the fly. Real-time recommendations.
I think I saw a blog on your site today about that, right? About the integration of those two for Neo4j and Elasticsearch.
Yeah, there was one a while ago that I wrote. But yeah, I actually talked last night at the Elasticsearch meetup about that. So, real-time recommendations, we've talked about that. Social graph, the way we interact, everything's connected. So that's a good graph use case. Fraud detection is actually a really cool one because whenever you're dealing, a lot of the fraudsters today use synthetic identities. And the basic concept of a synthetic identity is that all of the individual pieces of information are real and legit. So they'll use a real social security number, a real address, a real name, but they won't use the pair that you would expect to see with one individual. They'll take them from multiple individuals and mix and match them. So they'll put, John's social security number with Sally, and the bank account from Fred with that identity, and use the name Sally, and now you've got a new identity. And so if anybody checks the individual pieces of information that you would commonly check when you're on the phone or trying to check some transaction to see if it's valid, each individual piece of information checks out, and so it doesn't throw off any flags. But when you look in totality, or you're analyzing the network of connections, you can suddenly see, oh, multiple people are using this address, and they're using these accounts, and there's this money flow here, or multiple people are using this social security number. That doesn't look right. And so whenever you can do those pattern-based analysis for pieces of identifiable information, you can suddenly detect those in real time and do it very quickly. Yeah, real time is quick, but yeah. So in putting it all together, I recently built out a recommendation system for fitness programs and nutritional supplements. I basically went to Beachbody's website and started looking at, okay, if I wanted to do recommendations based on what they currently have, how would I do that? I noticed that they had the concept of fitness programs, nutritional supplements, and community. And so I was like, okay, that's interesting. They have all of those kind of organized by categories, which isn't really that interesting. It's not that personal to me. I can search and do that. And so I realized that I needed to introduce some new concepts. So I was like, okay, if I want as a user to get a personalized set of fitness programs or nutritional supplements that I should consume to help me meet my goals, I need to introduce the concept of workout goals, eating goals, body areas, muscle groups, kind of the things that are, so the things that I desire, the things that I want, the things that are impacted by fitness, by nutrition, and then different workout types, and maybe any physical limitations that I have. Because if I have asthma, you certainly can't recommend me heavy cardio. Like, that would kill me if it's really bad, right? And so there's some of these things where a lot of companies are missing out on these kind of filler pieces of information that can just make a very personalized experience. And it can happen, without too much work. So it didn't take me too long to put this set of data together. I just went through their website and basically took what they had in generic categories and looked and said, okay, well, they say these target abs, so that's going to, these fitness programs are going to be connected to, body area core. They're going to target abs, for example. And then started, once I had fitness programs in and connected to the workout goals that they supported and the nutritional supplements in with the workout goals that they supported, I could now start to build recommendations to recommend to user fitness programs and nutritional supplements. And when I brought in community, so I made different users with different personas, and now I said, okay, so I as a user, I'm going to use the edge with an importance weighting of how much do I care about upper body, how much do I care about lower body, how much do I care about core, how much do I care about full body workouts, how much do I prefer strength training versus endurance versus cardio. What are my goals? Is my goal to get fit, to just kind of have a wellness plan? Is it to performance? Is it endurance? And started ranking those as a user, which, anybody, if you go to a gym, the first thing you do is you sit down with a trainer and they try to understand you and learn about your goals. So even if it's a totally digital experience, you could still ask people that, because I'm coming to you so you can help me, live a healthier lifestyle or whatnot. So certainly I should be willing to spend, 5 minutes and fill out a few things and rate my importance of how much I care about certain things, or, provide any physical limitations that I have that would keep me from doing a certain workout. And so then once I had all of those in there and, I had my different workout levels like advanced or beginner or intermediate, you could start to connect all of it and bring together, different people. So Kevin, Ben, different goals like weight loss, muscle enhancement, performance, along with, fitness programs, nutritional programs, and then, I'll send out the links to these, but, you could even see that I could take two users and recommend they work out together based on their goals and their overlap and the workout program that they should do together. And so that kind of touches on kind of all of that connectedness, looking at the user, what's personal, what do you know about them, what's personalized, what are they connected to, how does it connect with your product, with your company, and then what can you recommend them to help them achieve their goals. Cool.
Round of applause.
Yeah, great.